equals 9. It's a nonagon. We want to find the sum of the interior angles. Remember the formula for sum of the interior angles? I'm going to write it backwards. Is that all right with everybody, or do you want me to write it the way the book shows it?
Backwards.
Backwards. So it's 180 times n minus 2. What do we put in place of n?
Number of sides.
Number of sides, which is 9, so I'm just going to put a 9 in there. So 180 times 9 minus 2. What is 9 minus 2? So 180 times 7. Somebody do that for us on their calculator.
1,260.
1,260. That should be your answer on that. That's all you're doing to find the sum of the interior angles. So any 9-sided shape in the world, what's the sum of all 9 interior angles? 1,260. 14-sided. Let's sort of move quickly here. What am I going to put in place of n this time? 14 minus 2. What is 14 minus 2? 12. 12 times 180.
2160.
2,160. Anybody else agree with that?
A nonagon.
Is it wrong? I don't have a calculator, so I'm just going by what Jenna tells me. If she tells me wrong, then maybe she just doesn't like the rest of you. She's just telling you all the wrong answers. What do I put in place of n this time? 16 gone, so 16 sides. Sorry, started to write it backwards. 16 minus 2 is 14 times 180.
2520.
2,520 degrees. Anybody else get that?
Yep.
Is that what you got, Jason? I just don't trust Harry anymore.
Well, I've tried, but he said it before I can even everyone out.
You, I trust
Ginger did the next one.
because Ginger's the mathematical goddess, right?
Yeah, I'm freaking.
180 times what?
18 equals 3240.
20 minus 2,
Oh, good, you did your homework from last time.
3240.
1840. Does everybody agree with that?
3240.
Oh, 3240. Does everybody agree with that?
Yes, but not on this face.
3,240. What's going to happen to the sum of the interior angles every time you get more and more sides? It gets more, it increases. All right, what happens to the sum of the exterior angles when you get more and more sides? Stays the same, nothing. 360 every time, right? Does everybody sort of understand that formula? N minus 2 times 180, or 180 times n minus 2. Molly, that makes sense? So stuff's coming way back here. It's not just stopping at Jason or something and not reaching you guys back here. Kelsey, is she lying to me? Is it reaching you back here? Next one, find the number of sides. These are a little harder. You might want to write just this first one down. Then I'll give you a second to write the second one down when we get done with the first one. So just write down the number of sides. Or I'm sorry, just write down the first one. We'll find the number of sides. Had a rough day today. Turn in this paper that we're doing right now. No, it's not all gonna fit on there, right? On the first one, sum of the interior angles is 720 degrees.
600.
So what we're doing is we're using the formula backwards. So we got 180 times n minus 2, and they're telling us that that should equal what this time? So we have this formula. The reason I want you to write this down is because I'm not always just going to say, give you an easy problem and say, here's the number of sides, find this. You can all do that. What you need to be able to do is use some of this stuff backwards, and that's what this is going to do. What we need to do first, get rid of those parentheses. So unlike on the other one, we can't do the subtraction in here. So we gotta distribute that 180 out. What's that give us when we distribute that 180 out?
180 and minus 360 is
When you're doing this, you're gonna notice when we do all these problems, guess what's gonna happen on this first part? It's always gonna be exactly the same. It's not gonna change, all right? Because n's what we're looking for, and that's what actually changes each time. How do I solve that?
Add 360.
Add 360 to both sides. Somebody help me out. What's 720
180
plus 360?
1080.
1080? Is that right?
Yeah.
Comes out to be 8.
We divide both sides by 1,000, or not 1,000, 180. On this side, that leaves us with just n. On the other side, what's 1080 divided by 180? 6. Everybody agree with that? What's n stand for again? Number of sides. So how many sides does this have? 6 sides. What kind of shape has 6 sides? Hexagon. I'm not sure what the question. I think it just said find the number of sides, so 6 would probably be good enough. Sometimes they might ask you what shape, so you might need that name hexagon. What should happen every time when we're solving these and we're trying to find n, we're trying to find the number of sides, what kind of answers can we not get? If we get a decimal or a negative, something's wrong, or 0, something's wrong. What's 2 other numbers besides all those you just named that we can't get? 1 or 2. There's no such shape. Right? So if n doesn't come out as some whole number that's positive, 3 or larger, then something's wrong. You did something wrong. Or there's no such shape. Number 8, how am I going to set this one up? 180, n minus 2 equals 1080.
180 in minus 360.
So you get 180 in. Notice it's the same thing, right? Minus 360. Ignore that string mark going up through there. Equals 1080. Now what? You guys just want me to solve it because you're all doing it on your own instead of watching me? That'd be easier. 180 n equals, somebody help me out there, I can add that in my head. 1440, thank you. Divide both sides by 180. What's n end up equaling? 8? Is 8 right?
Yep.
1440 divided by 180 is 8? So how many sides does that shape have? 8 sides. It's an octagon. If the sum of the interior angles of a shape is 1080, we know it's got 8 sides. It's got to be an octagon.
16 gon, 20 gon.
Next one. Notice, could we just jump right to this step right here?
Yep.
Because this side over here is the same every time. What's changing is that over there. So if you wanted, you could do that. I'm still going to write it out just in case. I don't want to confuse anybody. So this time we're going backwards. We're finding the number of sides. Instead of them telling us the number of sides, we're finding the number of sides on all these problems. 180 n minus 360 equals 2520. Add 360 to both sides. Somebody help me out, tell me what that is.
2880.
2880.
No,
Is that wrong?
No, that's right.
Divide by 180.
16.
What kind of shape do we have this time? 16 gone. Ethan, all that making sense? Easy stuff. Just using the formula backwards. If I do something wrong, please tell me. Did I do that right? So what kind of shape we got on that? 20-gon. 20-gon. Anybody got a name for a 20-gon? Give me an actual proper name.
Can we Google it?
Come on, I know some of you are taking French or Spanish or something.
Pentagon.
Huh?
Pentagon, something like that.
Ventagon? What's vintage? I thought vintage was 15. Quince is 15?
Yeah.
What's, what's vintage? 20, that's 20?
That's
Veinte?
These are from really
Oh, okay. So Veinte?
Why don't you know?
So could you call it a Ventagon?
Yeah.
Maybe. Probably not.
Set it up with wrong, and then everyone said I heard it wrong.
Has everybody got that much? No, not yet.
Yeah.
It's like back to something. It's something before that. I can't remember.
We ready? Next one, draw these two shapes. I'll give you a second to draw them again. Don't spend an hour drawing them. Just draw them quickly. The first one's got 4 sides. The second one's got 4 sides. They don't have to look pretty. Want me to sing to you?
Yes.
My wife likes this song.
Go for it.
Who said yes?
B.
I think everyone.
No, I didn't say it.
Well, that's her. She's out with
That's
other
one
people.
against everybody else.
There's a person.
Appreciate your confidence in me that I can sing.
I don't like when English sings speeches.
Dude, you sing all the time.
She's out.
Yeah.
I sing, but I don't like how other people sing. I like to listen to it.
There you go. At least you're trying.
I thought you changed your mind, bro.
Letters don't really matter on this, so you don't have to put in the letters if you don't want. The numbers for the angles do matter. What kind of shape we got in the first one? Quadrilateral. It's a quadrilateral. What do you know about the sum of the interior angles of a quadrilateral? 360. I'm hoping that that's one of them, just like a triangle. You know, a triangle's 180 every time, right? Quadrilateral's 360 every time. Start just having that in your mind. So if they got to add up 360, what can I do with these ones that we know? Add them up. Somebody add all those up for us.
296.
296. Everybody agree with that? What are you going to do with that 296?
Subtract it from 360.
360 minus 296. Somebody do that. 64. What's that tell us about this last angle right here then? It's got to be 64. So x has to equal 64 on that.
I was gonna point them out.
Yep.
The 66-degree angle looks like it should be higher than that.
Yeah. Don't go by my picture.
I could see the other, like, 130 and 66 being switched.
Might be.
See, really, you could just draw a square and say those angles are right.
Right. In the book I used to teach out of, when we got to the 4-sided figures, every picture they had drawn looked like a square
I couldn't do that.
because they wanted you to think about what you knew about the shape and not just call everything by what it looks like. Next one. Same idea on this one, right? How many sides? So we know all of it total up to 360. We got these
294.
294. Anybody else agree with that?
Yeah.
So what do we do with that 294?
Minus 368.
What is it?
66.
66. So what's x equal?
X equals 66.
66 in that case. Anything hard about that?
Nope.
Jacob, you can handle all that?
I don't think it's only addition and subtraction. Basically.
Everybody caught up to that point? Everybody caught up to that point? Yes, no, maybe? Draw those two. This one's got 1, 2, 3, 4, 5, 6 sides. This one's got 5 sides. So 6-sided, 5-sided. Give you a second to draw those two.
This is going to be.
How many are we gonna do?
That's why you got to back up the sheet of paper.
That man is a genius. You hear him just rhyme birthday with birthday. Sorry, I had to look it up. Wait,
On-
how many sets is the first one?
6. I was listening to what Alyssa was saying, confused myself. On the first one, you got 6 sides. What can you do to find what all these angles should add up to equal?
I don't know.
It should be 720. Could we use the 180 times n minus 2 and stick 6 in there? Yeah. And you guys probably figured it out already. What is it?
32.
720.
Oh.
Not the whole answer. Not the whole answer. Dawson, I know you're going to take that out of your ear too, right? Thank you, sir. So all these should add up to 720. What am I going to do next?
Add up all.
Add them all up.
650.
650? Those all add up to 650. What do you do with that?
Subtract its x equals 7.
Anybody else get that? That angle equals 70 degrees.
Oh.
Did you add something wrong, Dawson?
Yeah, I put 122, not 124.
Next one. 5 sides. We could do 180 times 5 minus 2. That's 540. I'm hoping that's another one of those that you just start remembering that every pentagon in the world, the 5 angles add up to 540. What's these 4 that they told us add up to equal? Say it again. 423. Peyton doesn't sound too sure. Anybody else get that?
Wait.
423.
423?
And don't you have?
What do we do with that? 540 minus 423. Alyssa said she got 417. Anybody else get 423?
I got 1.
Not gonna check.
Oh, 117 for this?
No, 4-7.
She's saying 417 for the total
I
here.
got 1, 2, 3 for the X.
It's 86 plus 140 plus 38 plus 59.
Try it again. Those 4 angles, add them up.
It's 4-7.
423?
Yeah.
And what equals is 170.
What's this then?
170.
117. So X is 117 degrees. Gotta be careful punching stuff into your calculator, right? Make sure you see it right. So you don't make a little careless mistake.
Wait.
Got it? Anybody else? Everybody's got it? Next one. It's got 1, 2, 3, 4, 5, 6, 7, 8 sides. This, 2 separate sides. There is an angle there, even though it doesn't look like it. 2x degree angle. skip this one, but then I looked at it and seen it the book. Sometimes you gotta watch out, cause I couldn't even see it, my eyes are so bad, maybe you guys could see it. But in the book, it didn't even look like that there was an angle there, it looked like it was just a straight segment. So if they put something in there like that, you gotta know, hey, that's a degree, so there must be an angle there. What do we say this has got 8 sides?
Yeah.
So somebody help me out if you got the picture drawn. 180 times 8 minus 2. 8 minus 2 is 6. What's 180 times 6? 1080? So all 8 of those angles in there should add up to be 1,080 degrees. We know that that should be our total this time. What's the first thing we're going to do? Add up the ones we know here. Anybody add up all those yet?
815.
Anybody else get 815? A lot of them to add this time, so I'm going to make sure. We don't want to just trust one person.
Yeah, I got it.
Harry's a pretty big fella, so he's got big fingers. He's punching in stuff on that little calculator. What could happen?
That's good.
Could miss hit a button, right? That happens to me all the time. So we got 815. What do we do with that?
Plus 3.
We could do 1080 minus 815. What do you get? 265. Now, does that mean this angle's 265? No, this time, how many x's do we have?
So X is 88.
So we're going to take 265 and divide that by what? 3. 1 x here, 2 x's there.
88 plus 3 repeating.
88, and remember, I don't like the 0.3 repeating. What is that as a fraction?
4.
1/3.
1/3. So 88 and a third is what x equals.
And then 2X is 176.
I think all it asks us to do is find x, right? So
Yep.
let's stop right there. Don't let it confuse you. Just because it comes out to be is it all right for this to be a fraction?
Yep.
Yeah. Is it all right for n on those other problems to come out to be a fraction? No, because that stands for a number of sides. You can't have a third of a side. But this one, it's all right for the angles to come out to be fractions or decimals. Everybody got that one? Draw those two. This time they want us to find angle X and angle Y. This angle, that angle.
Is that question 18?
I skipped some. It's number 19.
No, I'm talking about the potato.
Yep.
Yeah, that was 18. Potato. Oh, I'm sorry, the first one's got 5 sides, the second one's got 6 sides. Should've told you that. Somebody help me out. First one's got 5 sides. What kind of shape is it? How many degrees in the 5 angles in the pentagon?
540.
540 every time. How about for the 6-sided? How many degrees in 720? Hopefully you start knowing those. You don't have to do the n minus 2 times 180 every time. Flip. If you don't remember them, we wrote them down last time, right? In that chart, you could look back at the chart and figure it out. Doesn't mean you shouldn't know how to do the n minus 2 times 180, but how are we going to start the first one? We know all of them add up to 540.
164 plus 102 plus 90.
We know that that one there is 90. So add all those up, what you come up with?
Some number.
356.
356. Anybody else get that? Did you say that before, Lauren, and I just didn't hear you? So we take 540 and what do we do with it? 540 minus 356,
184.
184.
Yeah.
Divide that by 2.
We have these two angles that we're looking for, and the markings in them tell us that they're congruent. So all we do is divide that by 2. What do you come up with?
92.
So what's the measure of angle Y? 92 degrees. What's the measure of angle X? 92 degrees. Could we go back and check our answer and make sure it's right? What could we do?
Add all of them up.
Add all of them up, and they should total up to what?
540.
540. So go back and check sometimes, just to make sure. Second one, how do we do the second one? Add those up. This one here is 90, so add it in 2. 519. Anybody else get 519? What do we do with that? What's that give us? 201. See, we know these two angles are congruent, so we're going to divide it by 2 this time. 100.5, 100.5. So what's the measure of angle Y right there? 100.5, 100.5, whichever one you put. Ignore that straight line going out through there. Angle X. Same thing. Next one. First one's got 7 sides, 7 sides. If it's got 7 sides, how many interior angles does that have? 7. How many exterior angles? 7. So draw that real quick. Second one's got 5 sides.
This is terrible.
Remember, I am taking off points for your artistry.
Okay, sure you are.
First one's got 7 sides, second one's got 5 sides. We've missed 3 days, correct?
Yes.
Is that right? 3 snow days?
4.
We only have one left.
Oh, yeah.
We said go last call.
That's right.
What?
I was thinking.
We have one more, right? Yeah, and then
Okay, and that.
We're supposed to get a bunch of
After that.
I'll do it. Next one, we have to write something down. I'll freeze it and I'll go back there and I'll run along.
Oh, can I go grab my piece of the line?
No, because I haven't run it back here.
Well, can I still go get it?
Yes, Alyssa, I'll let you get up, walk back there and get them, and they'll be set right there next to it.
Thank you. Get some energy.
For the 7-sided figure. On the first one, for the 7-sided figure. Again, they don't have to be drawn perfect. We're dealing with exterior angles this time. What do you know about the exterior angles of a 7-sided figure? They always add up to 360. So what are we going to do with the ones that we know?
Oh, yeah.
Add them up. Somebody add up those 5 right there for us.
254. 254.
Alyssa's saying 254. Anybody else agree with that?
Yeah, I'm not gonna argue with you.
I'm not trying to. Everybody gets it before I do.
Is that right? 254?
What's wrong? We can laugh.
What do we do with it?
Minus 360.
360 minus 254, what do you get? 106. Now, we look here, we got two of the angles that are the same and they're both x, so what do we do?
Divided by 2x is 53.
53 degrees, so x equals 53. What's the sum of these 5 exterior angles add up to equal? 360 again. Sum of the exterior angles, always 360. Somebody add these 3 up for us.
162.
162. Anybody else agree with Harry on that? Yes, no, maybe? What do we do with that?
Subtractive.
What's that give us?
198.
198. Now be careful on this one. How many x's do we have?
Divided by 3x.
So we divide by 3.
66.
66.
Yep.
Everybody agree with that?
I don't agree.
If they ask us to, what's the measure of this angle? They didn't ask us to this time, I don't think, but 66. How can we find the measure of this angle? 66 times 2 or 66 plus 66? 132. Alright. You might be the mathematical goddess, but I'm still Mr. Ebersol. So.
I'm not. I'm slow.
Write those down real quick. Skip a little space. All right, on the next one.
Hey, record.
Got it.
Record the recording.
27. The answer is 108.
A pentagon says find each interior angle if regular.
Oh, that's my boss.
So we do. Give me 1 second. Back on track. My fault. 180 times how many sides?
5 minus 2.
Back up here. Then you're going to divide by that number also. All you're really doing is finding the sum of the interior angles, then divide by how many sides it has. All right, so don't make it harder than it is. Pentagon, you might already know interior angles of a pentagon add up to what? So this top part here is 540, so it's just 540 divided by 5. What's 540 divided by 5?
108.
So each angle in a regular pentagon is 108 degrees, if it happens to be regular. If I'm looking up here, that's a regular pentagon. That's what a regular pentagon looks like. So I know that that angle right there is 108 degrees. I know that that angle is 108 degrees. This is not a regular pentagon, so this angle doesn't have to be 108 degrees. All right? Next one, the 18 gon. Same idea.
28.
We're going to do 180 times 18 minus 2. Somebody do all that. What's that give us?
2880.
2880. Anybody else agree with that? Is that our answer?
No.
We take that and we divide it by how many sides we got, which is
160.
Equals
160 degrees. So each interior angle of an 18 gon is 160 degrees.
Wait.
35 gon equals 7740.
Next one, we do 180, 45 minus 2. Find the sum of the interior angles.
7740.
7740. Anybody else agree with Harry? Yes, no, maybe?
Yep. Divide it by
Divide that by
45 is 172.
172 degrees. Now notice, the more sides we get, what's happening to each interior angle? It's getting bigger and bigger, it's increasing, right? What's it never ever going to get past? 180, because if it's 180, it's not two sides anymore. It's not an
I'm
angle.
gonna get there.
Right. It's going to do like 179.99 would be the biggest it could ever get. Next one.
Then,
Equals 15,
3,418.
then,
3,418?
Yeah.
Don't sound right.
15,840.
19 minus 2, right?
90 minus 2, that's 88 times 180.
Yeah, that's not right.
What is it?
15,840.
That sounds better.
And then divide that by.
How come that didn't sound right to me? What should that last number be every time?
0.
It better be a 0.
Yep.
Divide that by how much?
176.
Yep, equals 176.
So what's each angle in a regular not 90-gon? 176. Kenzie's going to draw that not 90-gon for us, and she's going to show it to us by the end of class, right, Kenzie?
I'll do it.
That's a good job.
Let Alyssa do
wait,
it.
Mr. Eversole,
That's a good job. I seen that.
when you have a circle, wouldn't that be a whole bunch of teeny tiny lines, shouldn't it?
It looks like a circle.
And that's what you're getting. That's as we go up here. That's what you're getting closer and closer and closer to.
So here's my question. For that measurement to be 179.9999999, whatever.
How many sides would you need?
Yeah.
Figure it out.
It doesn't.
Next one, 34. We ain't got much time. We got to go. 34, regular decagon. Find each interior and each exterior angle. If it's a regular decagon, how are we going to find each interior, each exterior angle?
Gazebo. Yeah.
Now, this is, listen closely, this is where you might want to change up stuff, the way you're doing it. Is it easier to find the interior angles or the exterior angles? Exterior. Because the exterior formula is 360 divided by n. Well, this time, what is n? 10. Somebody tell me what's 360 divided by 10? 36. So each exterior angle, this is an exterior angle, is 36 degrees. If I was to draw this gazebo, which I'm not going to, it's going to be broke right there. If I could draw, if my pen would work right. If this exterior angle is 36 degrees, how could we find that interior angle? Easier way than what we were doing on the last slide.
Subtract that from 180.
Subtract that from 180. What's 180 minus 36?
144.
This is each interior angle. 144 degrees. So we don't have to, that last formula that we were just going through, doing this every time, doing all that math, we don't have to do that if you're looking for both. And it might have been easier on these last ones. Instead of using that big long formula, we could have just did 360 divided by 5, found that answer, then subtracted it from 180. Maybe that's easier for you. So here we would have done 360 divided by 45, subtract that answer from 180. Everybody got that one? No? So to get this 144, we just take 180 minus 36. That gives us each interior angle. We found the exterior angles first, then find each interior angle. Might be easiest to find each exterior angle first. These are a little tougher. Write down the first one. Then we'll do it. I'll tell you after we get done. This says each interior angle, so we got some shape. No clue what that shape is. It's cut off there, and I don't have any idea how many sides it has. But we know it's regular, and we know that every one of these angles is 156 degrees. How could we go about figuring out how many sides it has?
Mirror it. Like,
Now, we don't even know that this is half of it. We just know it got ripped off there. Could we use that formula? Each interior angle should equal n minus 2 times 180 divided by n. What do we know about each interior angle this time? 156. Could we solve that? And I'm going to tell you that's a hard formula to solve. All right? We probably don't want to do that. Same as the last problem. We probably want to find what for this? Each exterior angle. If this interior angle is 156, what's this exterior angle? 24? Does everybody agree with Jacob on that? What's the formula for each exterior angle? 360 divided by number of sides. Well, we're saying each of these exterior angles this time should be how much? 24. So you might want to write down there, find exterior angle. Find each exterior angle. Don't use the formula for the interior angles. It's a little more difficult. Maybe Molly wants a challenge, so she wants to use that formula. So she could punch in this. 156 equals n minus 2 times 180 divided by n, and solve for n in that formula. If you don't want that challenge, is this formula a little easier? Yeah, it's going to give you the same answer. Easiest way to do this, once you have it this way, put a 1 under that. When I put a 1 under that, it makes that whole thing into what?
Cross.
A proportion, right? So we're going to cross multiply. What do I get when I cross multiply that way? 24n. Everybody knows how to do proportions. What do I get when I cross multiply that way?
360.
360. What am I going to do to solve for n?
360 divided by 24.
Divide both sides by 24. 16? 15? So how many sides does that shape have? 15 sides. What should happen there again? If you're looking for n, give me something that your answer cannot be. Can't be a decimal, fraction, any of that stuff. It's got to come out as a whole number. Huh?
Can't be 1 or 2.
Can't be 1 or 2 either. What would I do first on this one then? 180 minus 165. Somebody tell me that. That's each exterior angle. Now tell me how to set up the equation that it's going to help me find the number of sides. 15 over 1 equals what? 360 over 10. Cross multiply. What's that give us? 15n equals 360. Now what?
Divide 360 by 15.
What's n equal? 24. So how many sides does this shape have? 24. 24 sides. Again, could I have done this formula? 165 equals 180 times n minus 2 divided by n, and solve that. What's the first thing you'd have to do if you were solving it this way? Multiply both sides by n to get rid of that fraction. Does anybody want to do it this way? I'll show you how to do it if you want to do it this way. It's easier probably to find the exterior angle first, then use that formula, right?
We should learn just to know both ways.
So if I do that, watch, I'm going to do it real quick while everybody's finishing up that one. 180 times n minus 2 divided by n. First thing you're going to do, multiply both sides by n, because that gets rid of that. This gives us 165n. We just did this like 5 times on one of the other slides. When I distribute that out, what's it going to give me? 180n minus 360. Now it's just like one of those other problems that we did. We add, no it's not. We subtract 180n on both sides. What's 165 in minus 180 in? Negative 15 in, negative 360. Now what do we do? Divide by negative 15. What happens with the negatives there? Cancel out. Somebody help me out. What's 360 divided by 15? 24.
So you get the same answer.
You get the same answer whichever one you do.
It's just one takes longer.
It's just this one. You see how long this one was compared to how long that one was. I'm not going to do these. We're going to skip over these. If it's each exterior angle, are we going to do the same thing? Yeah. All right, what I want you to do, up here, find your thing. These are your notes for today. You're going to start copying those down real quick so as you get back to your seat. You're going to come up here. If you wrote all that down, this is your chart, right? If you wrote all that down, you're going to mark, put a check in underneath there. Make sure I would put that. That's why I was trying to help Peyton out and tell him not to put it on that little sheet of paper. I would put that in your notes. Because that way, when Molly needs to refer back to it, will she have all that right there in her notes? And I'm hoping it helps her. She can ask. If she asks me, I'll.
Pull it back in and write on it.
Or are you saying I'm a chicken?
No, extra. Why are you proud of her bike ride? I can't put mine down.
Oh, wait, the line's over here.
4 years old.
What's the most you have so far? I think it's around. I think it's like 18.
I'm just trying to do this. I don't do this all the
Yeah, we actually have a good team. 8 of it was Hey, same. It was me and Dom. Last year.
Oh, I need to start.
Start copying real quick. Switch slides on me, didn't it?
They stick together when you
Gives me the right to make me a little bit. Sometimes I think.
Sorry, listen.
I did it already.
Okay, so what is that the way you're going to define normal size that you need to put the hole? I'm trying to figure out how many sizes it is. What size game? Or you can't game anymore.
So what we got to do is apparently 179.99999 won't work.
Acid or acid?
There's going to be a limit there. So you have to do
I need somebody to
keep going back until you get in your it's not just anybody. 179.9999999 probably isn't going to work because it's not going to give you a whole thing. So you have to go back and
I'm like so inside, but like outside the range that.
That's why I said I didn't. Right, quickly, parallelograms. That's the title. I'm getting ready to switch.
Wait.
Parallelograms. Know how to use the properties of parallelograms. Know how to prove a shape is a parallelogram. We're doing 2 different things today, 2 sections. So we're going to talk about the properties of a parallelogram, which I hope you know some of already, and how to prove something is a parallelogram. Title is parallelograms. That's all you need to write down off that. Parallelograms. Parallelograms. Now you can write this down. Parallelograms is the title. Then copy this slide. Everybody know what a parallelogram is? Definition of a parallelogram is a four-sided figure quadrilateral with both pairs of opposite sides are parallel. On the homework last night, there was some of these problems dealing with parallel lines. You got to remember those special angles dealing with parallel lines. Got to remember these two angles right there. What do you know about those two angles I just pointed at right there? They add up to 180. They're consecutive interior angles. You also got to remember what's true about those two angles. They're congruent. What's true about those two angles? They're congruent, so on and so on. Remember all that. Both pairs of opposite sides are parallel. This is the symbol for a parallelogram. It's the only four-sided figure that we're going to cover that has a symbol. All right? The reason. If I tried to start having a symbol for a square, what do you think the symbol for a square would be?
Square.
A little square. When I draw that little square, and I draw a little rectangle, and I draw a little parallelogram, what looks to be true about all of them? They all look the same, and that doesn't help. All right? So the only one of them that has a symbol is a parallelogram. All the rest of them, we'll just have to write out the names. Square, A, B, C, D. Rectangle, A, B, C, D. Parallelogram, yeah. Parallelogram, we put that symbol, just like triangle, put it out front, and then you go around the shape in order. Doesn't matter where you start at. So what's another way I could name this parallelogram other than A, B, C, D?
C-A-B-C.
B,
B-C-D-A.
B, C,
D-A-B-C.
D, A. That would work. Give me a name that would not work for this parallelogram.
C-B-A-B.
B, D, A, C, I heard, I thought. Why won't that work? You're like jumping corner to corner, that won't work. So you got to go around it in some kind of order. Say it again. A, D, C, B would work, yep. Diagonals. Oops, sorry. Diagonals. These are the diagonals of a parallelogram. Anybody see anything that looks to be true about the diagonals of the parallelogram? Draw this picture. Anybody see anything that looks to be true?
Intersection.
They intersect, that's true.
Quadrilateral.
This is the midpoint. Point B is the midpoint of what?
The quadrilateral.
That purple segment, and it's the midpoint of that segment. So what do I know about these two segments? They're equal, they're congruent. What do I know about these two segments? They're congruent. Does that mean all of them are congruent? No, in a parallelogram, see how it's tilted and one of the diagonals is always going to be longer than the other one? So those two are congruent. Can you tell me about this triangle over here and this triangle over here? They're the same. How about this triangle up here and this triangle down here? Same. Do what?
What's that bottom
I
right?
say though.
H. So the diagonals, what do the diagonals do to each other in any parallelogram? They bisect each other. They bisect each other. Any parallelogram diagonals bisect each other. Everybody pretty close on that one? These are all the properties of a parallelogram. They're actually theorems about a parallelogram, but they're also the properties. Notice every one of them starts off with what? If you have a parallelogram. So write all those down. I'll hold it in here for that, Sandra. Yeah, you can sit this wherever. once it drew it and it showed it to you, it would look like a circle to you probably.
Think about how big it was. Each side, like 6 inches. Think how big that would be. So what's the Earth? You look at the Earth.
It's not round.
I mean, obviously it's not any shape really, but if you made it into a shape,
It's not even really a circle because it's smaller at the center.
Yeah, it's got different. It's not a sphere.
Yeah, it's not a sphere. Is it like an equator?
So if you know a shape is a parallelogram, if I tell you that ABCD here is a parallelogram, you know all of this information. All right, so it's a lot of information. I'm going to put on here everything that we know once we know it's a parallelogram. First thing, we know opposite sides are congruent. So those two sides are congruent, those two sides are congruent. I forgot one on here even, and I should have, so let's put this on here, 1A. Not only are opposite sides congruent, what do we know about opposite sides? They're parallel. I don't know how I missed that one. That's the definition, right? Opposite sides.
It's down there. It's,
Oh, is it?
yeah.
Ah, I must have added it on. Didn't see it. All right. So opposite sides are congruent. Opposite sides are parallel. These two sides are parallel. These two sides are parallel. Man, my arrows are horrible. Opposite angles are congruent. Which angle is opposite angle A?
C.
C. So we know that those two are congruent. Which angle is opposite angle D? B. So we know that those two are congruent. We don't know all four of them are congruent. We know these two are the same, those two are the same. Consecutive angles. Give me a pair of consecutive angles. Angles are right next to each other.
AB.
A and B, I heard. So A and B. We know that those two have to add up to 180 every time. Is that the only pair? AD would work, DC would work, BC would work, so on, so on, so on. Any consecutive angles got to add up to 180. The diagonals, we talked about this on the last slide. If I draw on these diagonals, diagonals don't have to be the same as each other. They're not the same length. Some shapes will be that way. But they bisect each other. So this segment is congruent to that segment. This segment is congruent to that segment. Opposite sides are parallel. The diagonals bisect each other. We just talked about that. Opposite sides are parallel. The sum of the interior angles. What do we know about all four interior angles? They always add up to be 360. So if I drew this, told you it was a parallelogram, I told you this angle was 110 degrees. What can you tell me about this angle down here? 110. What can you tell me about this angle right here? 70. What can you tell me about this angle? 70. Every single time we know all that information. All that makes sense? Elijah, you can handle all that? Too much in your head? Did something else fall out the other side as it was going in?
Is it even possible?
Did you know who I was talking to when I said Elijah? You didn't lose your identity, right? You didn't forget what your name was.
Still back there somewhere.
Possible for all the angles to be congruent, or wouldn't that just be
It wouldn't.
rectangle?
It wouldn't be just a parallelogram. Then it'd be a rectangle because all of them have to be 90s. Usually, I'd go around the room and we do one piece of information on this. Could I get all the way around the room and everybody tell me at least one thing on this with all that stuff that we just said? Yeah. All right. So I'm not going to do it today just because we did that other stuff. It takes up too much time. Ways to prove a quadrilateral is a parallelogram. Notice on this. I'm not sure where this. Let me see. I'm going to do it this way. These are ways to prove that it is a parallelogram. Notice they all end with what? Is a parallelogram. So this is what we're doing to prove something is a parallelogram. All right? These are the theorems to prove it is. The others were the converse of these, and they were theorems saying if it's a parallelogram, we know this. So if we know it's a parallelogram, we know all that information. If we're trying to show it's a parallelogram, we can do it by one of these. I'm not sure why I didn't number all these. One of these 5 methods. So this is how to prove something is a parallelogram.
What's your favorite shape?
Never really thought about it.
I like squares.
That'd be a dodecagon.
12-sided, regular, or impossible?
And probably. I don't like pencil.
Is it just fun to say good pentagon? Are circles and ovals shapes?
Ovals are, circles are.
What are those things?
They're called ellipses. That's why I like poster over here. Oval was marked out as ellipse. Some math, non-math person made that poster apparently and called it an oval. That's what you call it here.
Maybe once you get older, you gotta call that.
You gotta know the actual name.
So,
So like a diamond, there's no such thing as a diamond. That's not a shape, that's wrong. It could be a wrong.
or parallel.
Or a square. The backwards. These are all the converse of those same things.
Well, I think that's.
Did you already use one page?
Yes.
How?
Because I'm taking this.
So is there any special term for like a perfect ellipsis that's like equal on both sides?
Yeah, there is a special name, I can't remember. On that, no, it's equal on all sides. When you have an ellipse has 2 radii. So it has radii 1, radii 2. Alright? If these are the same, if 1 and 2 are the same, guess what shape you end up with? You end up with a circle. So
But I mean like, because there's some that,
now there's different names for ellipses depending on how they're drawn.
Really? Wait a minute.
Some of it. They didn't
Wait a
teach
minute.
you the
That's
drawing.
an oval. Not, why is it called an ellipse?
There's no such shape as an oval.
Why? Why
Because
is
the
it
proper
not called
name is an ellipse.
No, I know what an oval is. It's like this.
What's a shape called where it's like an egg shape?
That's it.
yeah, what's the better
An
term?
egg shape. It doesn't really. It's not really a shape.
It's like, it looks like a.
So it's bigger up here and smaller down here. It's not really a shape.
Is that also an ellipsis?
It's just an egg. Not really, because now you're taking your ellipse and instead of splitting it like this, where the two sides are exactly the same. You're splitting it up to where this side over here is different than that side over here. So like this part up here is the same as this part. This part. So it's not really the same thing. Does everybody have this? We got to move along. Those are the midpoint distance formulas. If you want to write them down again, they're up there. I'm going to skip this slide. I put them back because apparently on the homework, what are you going to have to use again? Probably those formulas. On this, if this is a parallelogram, we're going to do this real quickly. If this is a parallelogram, what do you know about these two segments? They should be equal. What do you know about, let's see here, what else do we have? Once we find x, could we find the length of this?
Yep.
What would we know about these two? They'd be the same. What do we know about, if this side's 8, what's that side over there? 8. If this side's 13, what's this side? 13, so on and so on. What do you know about these two angles here in the middle? Congruent because they're vertical angles. How about these angles? Congruent, so on. We know all that. If this angle's 48, watch closely on this. This is something I didn't say on the other part. If this angle's 48, tell me what this angle over here is. 48. Those are alternate interior angles, with those two sides being parallel. If this is 10x, what's this one down here? 10x, so on, so on, so on. All that information, you know all that. Your assignment's on those 2 pages. We were going to work some of it together, but instead I decided to do the other homework together.